My name is Paul Tice with ToPa 3D. I want to walk you through why 3D scanning is invaluable to the BIM process and creating as-builts. From the models, we're actually creating drawings that can be used for your design. This process begins with 3D laser scanning. This is a terrestrial laser scanner device typically. It can also be hooked up on drones, or it can be a handheld scanner. And the terrestrial laser scanners that I'm going to be primarily focusing on for this application sit on a tripod. They fire about 1 million laser points per second, and they give you a 3D sort of visualization that's measurable within about 2 millimeters for each scan. Scans take between 3 to 7 minutes per scan, and what we do is we leapfrog them through the building and we collect all this 3D data and stitch it together like a jigsaw puzzle for the final point model, and that model can be translated directly into a 3D Revit model or a BIM model. And what that brings us to is accurate as-builts. There's nothing more accurate than having 3D scans of an entire structure and then translating that into a 3D model like Revit. The Revit environment allows you to actually print out construction drawings right from the model. So if you make a change in the model, it automatically changes dynamically all the other aspects of the drawings, which is a great feature for anybody who hasn't used that yet. Why do we use 3D? Well, 3D provides context. It's creating 3D images of a space, so you have the ability to really understand visually what's going on with that space, rather than going out and taking a few photographs and hoping that you've got it all. It also provides clarity, so when you're trying to communicate that to project teams, you have a very comprehensive understanding of what's in that 3D space. This is especially useful for remodel work or any kind of piping facilities that's very complex. The 3D scans provide geometry, and from the scans I said before, you can translate that geometry directly into a 3D model for Revit, so you can have an editable sort of design model for that purpose. The geometry from the 3D data is measurable. Most of the work that we do at ToPa 3D is measurable data. We provide precision models, and that allows you to take measurements on the fly as you're in the field using your iPad, which is one of the things I'll talk about later. And also just through the Revit model process, you can take the measurements right from that after you've translated the scan data into the model. 3D data is versatile. What I mean by that is that you have the ability to use 3D data on a lot of platforms these days. SketchUp, ArchiCAD, AutoCAD, Revit, Bentley Systems, MicroStation. There's hundreds of 3D platforms out there. And I think the other thing I should mention is they're interoperable. So you can take data from our process and probably plug it into just about anything that you're already using in your workflows. And that translates to absolute accuracy. So when you have this kind of data that we're providing with this 3D scanning and so forth, you are getting absolutely accurate data of that space for your as-built modeling process. What we're using when I say 3D scan data is LiDAR, which stands for Light Detection and Ranging. LiDAR is a very robust data that you can translate into 3D models, but it also can be viewed through their own sort of proprietary viewers. So when we do scans, we also provide ways to visualize those raw scans and take measurements from the raw scans. So it doesn't necessarily have to be translated into a 3D model to give you the ability to measure that space. We can do it from the sky, we can do it from the ground, and we can do it from a handheld device that allows you to take measurements at about 4 mil accuracy, actually, so about 1/10 of a millimeter on the handheld scanning part. And all of this LiDAR data, which is what we're going to be starting to call, for the rest of this presentation, point clouds, can work with each other. So if I scan from a drone and then scan from a tripod with a more accurate scanner, and then scan again from a handheld scanner, like to do an artifact or a sculpture on a building, we can integrate all of those data sets into one large contiguous data set. So you can have a large, very accurate 3D point cloud model that shows it from a large macro scale all the way down to a micro scale, all in one visualization. Using drones, we can attach 3D scanners, LiDAR units that have GPS and IMUs and all kinds of interesting sort of self-localization and 3D location devices so that you can create point clouds from the sky for those hard-to-reach areas. Terrestrial laser scanning. These terrestrial scanners can actually, as I said before, leapfrog through the building, firing 1 million laser points a second and capture in full photorealistic visualization the space itself. So you actually have the ability to measure from nail to nail head. It's extremely accurate and very robust. Depending on what your goals are of the project, we have the ability to capture it in a general sense using a few scans or getting down to the details and capturing a great deal of information such as a piping facility. Handheld scanning, a very interesting technology. It uses what's called structured light, which is really 2 stereoscopic cameras that are firing at the same time at every flash of an LED light. And what that does is it models on the fly. So in this example, you can see one of our techs actually modeling a turbine blade for a hydroelectric dam for reverse engineering purposes. LiDAR also provides visual reference options through the proprietary software. So using LiDAR in the sense of terrestrial scanning for this example, we scan the old Capitol building in Olympia, Washington, and from that you can look at it from a map point of view, from the left to right, from a photorealistic visualization point of view. You can see the entire structure in 3D as in context as a 3D model. We can create ortho photos directly from the scan data so that you can have a large spread of a facade, for example, and take measurements off that facade, or just bring that raster image scaled directly into an AutoCAD or any kind of CAD platform and trace out the features on that facade. And that's a great application for HABS drawings or historic preservation applications. Also, we have the ability to integrate this scan data into a virtual tour so that you can leapfrog through the scans almost like a Google Street View, but you can also have this integrated on your iPad so that you can take measurements on the fly as well. The 3D scan data also can be integrated into a workflow that does the client a great service in MEP System Verification. One of the most abundant applications we've had for terrestrial scanning is to go into structures that have been partially built to verify where contractors have installed different sort of MEP systems, mechanical, electrical, and plumbing systems, as well as fire suppression. So with that, we can actually take measurements directly from the architectural features such as walls, beams, joists, and show you in 3D exactly where those are to the millimeter. So that's a very common application for 3D scanning, is verification of how things were installed. That leads us to this process which we call scan-to-BIM. So creating 3D scans is one thing, and having the ability to measure them is awesome, but we also need to have it into a design model a lot of times so that you can redesign for, say, a remodel. So 3D scan data and scanning for the purpose of creating a BIM model is the most efficient method for creating dynamic and editable as-builts from complex subject matter. The more complex, the better the application. You could send a tech to the field to take all these measurements, and that's okay, that'll work. However, that can also lead to a lot of error and a lot of time and wages. And of course, if somebody makes a mistake, then we don't have a way to really measure how much that could possibly cost the project. It's cost sometimes upwards of thousands, hundreds of thousands, or even millions of dollars for huge mistakes based off poor as-builts. So what problem we're solving here is really creating accurate as-builts the first time. It only takes a few days to do, and then it's done. And you can design right off of those for the rest of the life cycle of the project. So here's a photo of some raw 3D laser scans. This was of a hospital project that we did. Then we can translate those scans as a typical workflow into recap files, which are Autodesk-based files that can be read directly in Revit. Then the Revit model was extracted from the 3D scans. And we have this ability to, of course, design upon that Revit model and make it even more complex and add features that maybe are not existing in the field yet and can actually support the design process through the model. And of course, through the model, you can create as-built drawings very quickly because it auto-translates them into 2D construction drawings. And from there, you have the ability to print them out and work off them, do red lines, and then update those features and notes directly back into the model. So you make one change in the model, you move one pipe, and then that pipe is moved on all sheets, on all elevations, all plan drawings, all sections, and all reflected ceiling plans. Wherever they are, they're going to be auto-changed throughout the entire model. And then you can just reprint them out, and you'll know that all the updates were applied to all sheets. The last thing I want to mention is that LiDAR and the models actually can be integrated to mobile devices. So if you want to take your iPad Pro or your Microsoft Surface tablet out to the field, you can do that. And you can have this data right on the tablet, and you can work with it right there as you're walking through with your hard hat on and showing inspectors what you've got. In summary, I just highly recommend 3D scanning to create your as-builts. There is no faster way or more accurate way to create as-builts than by using 3D laser scan data, especially for complex infrastructure. We at ToPa 3D are experts in integrating the scan-to-BIM workflow into your workflows. So please contact us if you'd like to know more information about this and how we can consult with you to integrate this already existing and proven technology into your company. We look forward to consulting with you, so please contact us through our website at www.topa3d.com and have a great day.